Okay, what I got here is a can, and I'm going to put water in it. And I'm going to take a torch and heat her up to the boiling point. And what I do with my cap. I'm going to put my cap on there just a little bit. Not tight all the way. And well, let me zoom down here. Show you my torch under there. And you can hear it running, heating up that water. And what I want it to really do is boil the crap out of that water in the can. And I hope my background there stays put. It's getting a little windy, but we're going to zoom in on the cap here so we can see it when it starts really steaming. And I wish it wasn't so windy, because it's not kind of taken away from my my torch to heat that up, unless I can. Let me see if I can find something to raise it up a little bit, get it closer to the bottom of the can. This might work. That way maybe the wind won't affect it as much. So I've got my, it's like a Bunsen burner. It's just a torch. And I really want it hot and steamy in there. And boiling like a mad dog. Hopefully I can do this in the 15 minutes. It's either that or I'm going to have to shut it off. And have two rags available, one to hold the can and one to tighten the lid up, because I don't have that lid on there real tight. Like I said, I want to try to keep as much steam in there as possible. Maybe I ought to loosen it up just a little bit. Maybe I got on too tight. I don't want it really steaming. I'll get out of here. Actually, I'm going to open up the lid here and look down inside. The water's just now starting to boil. Once I see some steam coming out of it, I'm going to put my lid partially back on it. And I also want to zoom back here and let you look at the whole can. It's got a few dents in it, but it's not dented real bad. But here, let me zoom in on it here. That way you can see how much it actually is dented in. But that's just, it's an old work, you know, was used for work. It's just an old can, empty can. And I'm starting to get a little steam out of it. I hope you can see the steam. Yep, you can see the steam coming out a little bit. What I'm going to do is partially put the lid on it. The can's hot for sure. And then I got another can, or another rag too, to tighten that lid up when it comes time. We got some clouds rolling around up here. You can start seeing the steam come out of it pretty good here and there. I still want it to be really, really boiling inside of there. Want to make sure you can see the whole can too, and like I said, I might have to turn the camera off and then turn it back on, but I'm going to let it boil a little longer. Actually, there's 5 minutes left on this. I'll let it boil the rest of the 5 minutes. I'm going to turn it off and then turn it right back on again. Tighten down the cap, remove the heat. Come on, stand up there. Damn wind ain't helping none. I also like my heat to be a little bit more closer to the can. Just to really get her boiling. Rapid evaporation. He's really starting to boil now. Really starting to steam. And what I want to do too is let me set some blocks up behind it, so when I take this off the heat, you'll be able to see the whole can, because that's what I want you to see, is the whole can. There, I got a paint can behind it that I can set it back on once I take it off the heat. Alright, actually I'm going to turn the camera off, turn it back on. We'll zoom in a little bit on it here. Okay, I turned it right back on. My battery's about ready to go dead too, which sucks. I hope it has enough juice to keep me going. Alright, what I'm going to do is I'm going to take the heat off of it and tighten down the cap, or tighten down the cap, then take the heat off. I hope you can see the can. Hear the can. Like I said, I hope I got my lid on tight enough. seems to be. Well, let's let it sit there and cool off and see what happens. Well, I ought to show it to you from the side here, show you what it's doing. Holy crap, look at there. Look at that can. In a vacuum, baby, in a vacuum. So what I did was I created a vacuum inside the can because the water vapor just condenses back to water, and this is what it's doing. I wish I would have turned it sideways and showed you it from the side, but it's still slowly crushing the can. And let me take you back around the front side here. I'm going to show it to you this way. And you can see what happened to it. You can try this at home if you want. I mean, you know, wasn't nothing fake about it. It's just, yeah, I guess you have to do it right, because this was my second time. I actually let a lot of the steam out when I was had the top open, and didn't have a good seal on it with the other can that I was using. I got another can here. So in turn, let me just pick it up and show it to you now. I mean, you know, the whole can is crushed inside. So, you know, when NASA goes into space and you know, they got their spacecraft pressurized in a vacuum, just think that this would be the opposite of what would happen if you have air pressure inside. The opposite happens. Now somebody, you know, said, "Oh, you know, the vacuum isn't that strong." Well, if it's strong enough to suck the can inward, what would it do to a bigger craft that's pressurized out in space in a vacuum that's actually, you know, basically made out of aluminum or tinfoil, tar paper, duct tape, because that's what the lunar module looked like. So in turn, you know, try this little experiment at home yourself. Just do it right, and you'll get the same results. It literally crushed that can. And I do have another can here. I might even do it again and then turn it sideways so you can actually watch it sideways, as long as I didn't ruin the seal on the can. So let's try another one, so y'all ain't thinking I'm bullshitting you here. But I do need to change a battery too on my camera. It's getting a little low, but next time I'll turn it sideways so you can actually see it from the side view of it instead of the front view. Alright, I hope you enjoy watching it, and like I said, I'm going to do a second trial. Round two. I'm going to show you the whole can first and show you that it's just a tin can, and I'm going to set it here, and I'm going to fill it up with water. And this is going to take a little while because I have to boil this water that's inside of here. And I'm going to put a cap on it part way. I'm not going to tighten it all the way down. I'm gonna get my torch, which I'm torching it from underneath. I don't know if I can bend this thing down to show you the torch, but here we go. Okay. And what I want to do is heat that bad boy up to where the steam is steaming in there. And I want a background where you can see it steaming. So you've seen the can. It's not dented or not squashed anyhow, like the previous one I just did. And I wanted to do this twice to show you that this is very possible and very easy for somebody to do themselves. Think about the bends that a scuba diver would get if he rises to the surface too quick. You know, you think about going from a vacuum back into, you know, back down to earth. Wouldn't that also have an opposite reaction? Instead of your lungs exploding, they would probably shrink to nothing. At least that's, you know, an opposite reaction to you know, the action of a scuba diver. So take that into consideration too. I think that would make a big difference, or it should be something that, you know, we should think about. All right, think about it. This is all in reference to, you know, they put a you know, in a submarine goes down into the water. What do? They pressurize the submarine so the submarine can withstand the air pressure. And here's the can that I just did the test on right here. You can kind of see it off to the side, what it did to it. And look at perspective wise, that can's back a little bit further, so it looks a lot smaller, but it's actually the same size can. So put it in front of it, it blocks it out, of course, because of perspective, but it is the same size can, and you can see what that vacuum did to it. But, you know, getting back to a submarine is pressurized to keep the water pressure from squashing it. So if you go out into space, into this infinite vacuum, in a spacecraft that is pressurized, that they have pressure in it, because of course, you know, you gotta have pressure so they can have oxygen to breathe. You know, what is it? Newton's law of physics. For every action, there's a reaction. So you would have the opposite reaction in space that you would in the water with pressure, going deep down in pressure. So in turn, you know, this is an experiment just to show you that the vacuum would be pretty powerful. So again, I might have to do this in 2 parts, so the video may be long, but it's worth watching. And like I said, have 2 rags available or 2 gloves so you don't burn yourself. And what I'm waiting for is for the steam to come out of this cap. And once that water's boiling really, really good, which I'm going to look down inside, it's not boiling quite yet. It takes a little bit, but I didn't want to cut it out and then have somebody say that you know, I faked it by putting the other crushed can there. But I will have to turn the camera off and turn it back on, but I will show you that this can is still the same. There's no dents or squashes to it. But this time what I'm going to do is turn the can sideways on the paint can that I got setting up behind it. So you can actually see what it does to that can. In the front angle, it wasn't as pronounced, or it didn't really show the detail as much. So, you know, going into space, like I said, I'd like to see one of these astronauts get into the vacuum chamber that they've got, I mean, in his full gear, and have him suck all the air out of there, and see what happens to him. You know, my thought is he'll pop like a kernel of popcorn in there, because his suit's got to be pressurized with air pressure so he can breathe. So, you know, anytime NASA wants to stick one of his astronauts inside that vacuum chamber and show us all that it ain't a bunch of fake bullshit, I'd be happy to see that. I really would. And I actually think that they should put Neil deGrasse Tyson in it, and let him be the example, being that he talks about gravity, space, and how it's real, and whether you believe it or not, it's true. Okay, so if it's true, Neil, get inside the vacuum chamber in an astronaut suit, and let's see how long you survive in it when they suck all the air out. Plus, too, I think it was Curious Life to put up a video, and then they made him take it down because he used copyrighted material where they show the bowling ball and the feathers falling at the same time. Well, if you're in a vacuum, like they show you in space, where there's zero gravity, why would they have fallen at the same time? Shouldn't they have floated? I mean, the feather should have floated and the bowling ball should have floated. So all they showed you was that density works in a vacuum, and because it's a vacuum, it keeps the same density as the bowling ball and the feathers keep an equal density, and they both fall at the same time, because there's nothing there to hold them up. Another thing too is while Neil's in there in his spacesuit, I like to see him stick say a Roman candle up his ass or something, and light it, and if they can light it, and see. Or how about a little rocket, you know, a little bit of fireworks. See if it blows his asshole apart, or see if it even takes off inside of the vacuum chamber. They don't show you that, which I think they should. Number one, I don't think that they would be able to light anything without any oxygen, or if they were able to light the fuse in a vacuum, it wouldn't do nothing. If they had a bottle rocket, or, you know, another type of firework rocket, I don't even think it would take up off the ground. You know, I think it would be just like a big dud. So in turn, you know, what have they proved to us? They don't prove nothing. They haven't proved shit. So let's see, I'm starting to get a little bit of steam out of this thing. Oh, there we go. It's starting to steam pretty good. And I'm going to let it steam for the remainder of the 5.5 minutes here. I'll shut my camera off and then turn it back on. Remove the can from the heat, or tighten up the lid, remove the can from the heat, and set it back, and I'm going to turn it on its side instead of forward straight at you, so you'll be able to see what happens to this can in a vacuum. And maybe this will give other people some ideas. That's what kind of my channel is about, is just giving people ideas and trying to make them think for themselves instead of the damn belief system that we're given. You know, it's a belief, because we don't never get proof. Where's the proof? The proof is in the pudding. So show us some pudding, Neil. Get your ass in that vacuum chamber. And, you know, if all your astronaut buddies want to hop in there with you, you know, maybe we can put it into NASA right off the bat with just that proof, instead of wasting all of our taxpayers' money. Hey, Mrs. Boo Boo. That's my girl. My four-legged child. Yep, he's my baby. He's my baby. Don't get near the heat, though, okay? Don't get near it. It'll burn you. Alright, we're down to a little over 3.5 minutes left. And I'm starting to get some good steam coming out of this can. Let's see if I can zoom in on this lid a little bit so you can see the steam. Yep, there you go. See it steaming. That's why I put the blue background behind it so you could actually see the steam. And then I'm going to zoom back again and get this whole can in frame, because I'm fixing to turn it off and do what I said. I'll screw the lid on real tight and take it off the heat, and then set it back on a paint can that I got behind it, so it's off even the heated blocks that I got this can being held up from. And again, be careful. You don't want to burn yourself, so make sure you got rags or gloves, so when you tighten up that lid, you're not burning the shit out of yourself. Alright, actually I think I got a minute left on here. I'm going to shut the camera off, turn it back on. Actually I'm going to zoom in on the lid. So you can see it steaming. Yeah, the wind's blowing real hard now. There's some steam. Alright, so I'm going to zoom back. I'm going to shut my camera off. Let me get the whole can in the frame here. Okay, I turned it right back on. Now what I'm going to do is I'm going to tighten the lid, take the can off the heat, and turn it sideways for you. Pop. Might not have a good seal on this can. Let me check the seal out. The lid's on tight. Give it a little bit because it just doesn't crush immediately. And this can is a little older, but there it goes. Hey Neil, you want to get in there? Oh my goodness, look at this. Crunch. So yeah, a little test that anybody can do at home. This is an old damn tin can. It's like, I think it's a gallon tin can. So yeah, it's just something, like I said, I was taught as a kid, and it just dawned on me to do this. I mean, I thought about doing it before, but you know, I wanted to do it on film so people could actually see what it was doing to the can. And you know, the more that can cools off, the more it does crush. But it's only going to crush to a certain point. So come on, tell me that you want to go into space in this vacuum. Alright, I hope everybody liked my little experiment, and maybe it inspired them to do something similar, or maybe it inspired some other idea in their heads, and they'll come up with something else to show. But I hope I get a little more views on this one than some of my other ones, but the views ain't even mattering anymore. As long as I get to show you know, what I think, in my opinion, I'm happy just doing that. Alright, thanks a lot for watching, and there's a little bit more to this. I'll let it finish. So, you know, here's this can that I did my second test to with, so you can kind of see that the backside isn't crushed as much as the front, but this one I think I added more water to, and you can see it even crushed it a little bit more. It ain't hot. This one ain't hot no more, but the other one sure is. It's a little warm, but you know, you just look at this can, how much it crushed it. You're just creating a vacuum inside of the can. So think about the vacuum on the outside of the can with the can pressurized. If this can would have been pressurized and we would have had the vacuum on the outside, it would definitely have done something. So anybody that has one of those little vacuum chamber things where they can put objects in it, you'll find one of them, I think they're like 8-ounce Coke cans. They're the little mini Coke cans. Put one of them inside of there, you know, shake it up, put one of them inside of there, you know, create some pressure in it, and see what happens when you start sucking all the air out of it. See if that can explodes. That would be a really good way. I don't know if it'd ruin your machine, but that would be a really good way to show, you know, how things work. That is still a little hot, but you can obviously see, you know, both cans got crushed. Either way that you look at it, you know, that's a vacuum inside of a can. So again, the opposite reaction would be the can would probably explode. So that's my little vacuum experiment. Hope you enjoyed it.